All right, is it really true that the older amps are able to deliver more low-end energy for longer periods of time than the newer Class D amplifiers? I've heard quite a few people tell me that these older amps are able to deliver long, extended bass notes for EDM, and they have this more robust power source than the newer Class D amplifiers. Is it true? Is it false? What's really going on here? Let's compare this Class H, which is a Class AB amp with dual power rails and has a conventional power supply, to a newer Class D amp and see how they perform. But let's look at more than just what the outputs are, because we want this on a level playing field. Which one weighs less? Which one puts out more watts per pound? Continuous watts, long term. I'm not talking these peak watts. I'm talking about the watts that the EDM shows are looking for, these long extended RMS values. Watts per pound, watts per cubic foot, watts per dollar, and efficiency, watts per breaker size. All right, let's measure them up. This Crest 7001 is 15.5 inches, and the L-Acoustics LA12X is 16.5 inches. And if you count the connectors sticking out the back and the handles in the front, or if you want to call those handles, it's about 18 inches. And if we count the handles here, we're looking at about 17 inches, 1 inch bigger. The Crest 7001 is rated at 1800 watts. 900 watts per channel into 2 ohms. The L-Acoustics LA12X is rated at 2600 watts per channel times 4, 10,400 watts. Quite a big difference. Let's see how much they weigh. So we'll start with me. And I weigh 161.8, 161.6. And we'll pick this guy up. Wait, first we gotta reset the scale. And I'm about 212. So that's about 50 pounds for the Crest amp. Let's check the L-Acoustics amp. 194. So about 33 pounds. 33 versus 50. All right, so we've got our weights, we've got our sizes. Let's see what the power output is. So I've got my hot plate here. Actually, it's the load, and I've got a bunch of high power resistors underneath there, and it tends to overheat, and I don't want to blow up my load, so I need thermal indicators. And the thermal indicators I'll be using today is a Kit Kat bar, which we will place on the left and right extremity here. We have a Reese's Peanut Butter Cup. Now this should be a good central indicator, so we'll place that in the middle, which will give us a good idea. Litter here. The Snickers bar we'll place downstage, and its close buddy, the Milky Way, will be upstage. And I've got a Hershey bar. We'll leave that to the side. I don't think we're going to need that. But we will want some sort of indicators in between. So we will use the gummy bears and place those across. And there we have it. We have, this guy can sit on top of the peanut butter cup there. Okay, we have our thermal indicators in place. And we've got the amp, we've got the scope here, and I've got the Sound Tools mic switcher swapper. So in the A position here, it sends the Lofttech tone generator to the amplifier, and we can also see it on the scope. And I've got this scope set for a fairly long sweep time, and we're set at 100 milliseconds per division. I'm going to do some fairly long testing, but I don't want to go too long because it will blow the breaker on the amp. And I'm running 10 gauge, 5-wire, 50-foot cable power tap directly into the main distro for the house. And that's here. And this right here is my handy dandy, let's go ahead and unplug it. This is my double Edison 260 amp circuit breaker. And I highly recommend that you do not make one of these. It's a dual Edison, and when you plug one in, the other becomes hot when it's on. And what that does is it shorts together these 10 gauge wires so that I'm running double 10 gauge on the Edison here. So it's 50 foot of two 10 gauge wires in parallel when I turn this switch on, and it's a single 10 gauge when the switch is off. And that allows me to look at the current draw over thicker versus thinner wire. And we'll do that in another video, but that's what's going on. And this right here, the current clamp, will clamp onto this Edison here, and it'll tell us how much current is drawn by the amplifier. So let's go ahead and burp this thing and see what it does. And this speaker is hooked up to listen to the output at a very reduced level. All right, so that's our waveform there. It's moved over a bit, but we can see that our voltage is 42.59 volts. Does that line up? We've got 50 volts per division, 50, 100, and 20, 130 times divided by 2, 65 times 0.707. So we take the voltage squared, 42.59 times 42.59 equals, and then we divide that by the impedance or the ohms, and we have 906 watts on channel A. Let's try channel B. 42.7. Okay, so channel A and channel B put out about 900 watts. I've got this amp hooked up with the polarity reverse, so we can actually see what it does across the two hots, the equivalent of bridge mono into 4 ohms. We should see some higher voltages. 93.25 for the combined channels. 93.25 times 93.25 equals divided by 4 equals 2173. It's showing up over that. Maybe we're clipping. No, yeah, we are clipping a little bit. Let's bring it down to not clip. In any case, it's about 2,000 watts coming out of this thing. 50 pounds, 2,000 watts. Watts per pound. 2,000 divided by 50 equals 40 watts per pound. That's what this amp is giving us. All right, well, that was some short intervals, but what happens if when we push it? How long can it sustain this kind of output levels? Let's go ahead and find out. Let me fix this thermal indicator here. All right, so we'll go ahead and fire this up. And we're driving hard. I'm going to go ahead and boom, we blew the front breaker on the amplifier. Didn't want to do it. I'm going to go ahead and hit it again. Now notice on the waveform, it's holding steady. It's going and putting its output voltage and staying there. It's able to deliver full power and consistently hold on to it until the circuit breaker pops. Let's do that again. And we're distorting a little bit. And boom, we blew the breaker. But until that breaker dies, this baby is just giving it all it's got. Cool. All right, let's go ahead and try the LA12X amplifier and see how that performs. And we will zero that out and go ahead and hit it. 17 amps. Well, that's interesting. It's only drawing 17 amps instead of drawing 40 amps. And there's our output at 81 volts. Let's go ahead and give it a more juice. Right below clip. And it says we have 93.52, 21 amps of power of current pulled. And let's look at the waveform. Let's see if it's holding steady. It sure looks like it. I'm going to go ahead and watch what happens when I add more copper to the line. Whoa! All right. I think we took that out. Something is not going to work as well as it did. Okay, we're back and running, minus one of the loads, but I've got 4 1 ohm loads as well. So I've put that together for the one that died. And we will light this up. All right, so now look at what we've got. We've got the full output power for 251, 250. So we've got almost a full second of full output power, and then it reduces down to a lower voltage. So it's trying to do it with all 4 channels driven, but then dropping down. And this is why I believe people say that the Class D amps don't deliver full power. They don't. When driven hard for long periods of time, we are not able to get 10,000 watts out of this. Is it 10,000 watts? Let's check it out. Let's go ahead and restart this. How much power are we getting? Well, we're pulling 93 amps off the wall. And we've got, let's go ahead and hit it. $90.58. So let's go ahead and see how much that is. 90.58 times 90.58 equals divided by 4 equals, that's 2,000 watts with all 4 channels driven. Based on that, what happens if we go down to just 1 channel? 93.72. Let's go ahead and look at all 4 channels driven again. $92.55. Cool. Okay, so all 4 channels driven. Oh, our gummy bears have really indicated some heat, whereas we haven't really reached the chocolate melting level yet. Maybe we should have used the Hershey's. I think this might be a better indicator because it doesn't have solids inside of it. So we'll put that there, 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 and here. All right, here we go. All 4 channels driven. Look at that. We've got, oh, it went away. Let me do it again. That should stay. Look what's happened here. We've got our 92.59 volts. 92.59 times 92.59 equals divided by 4 equals 2,143 watts for one of the channels with all 4 channels driven. But it's dropping down to this lower level, and we can see what that is. We can just calc that off of the scope here, and then we can lower this down, and we see what the voltage is here. And we can raise this up. And it's saying that it's dropping down to 164 volts peak to peak. or 82 volts, 82 times 0.707 equals 57,594 times 57.594 equals divided by 4 equals. It's dropping down to 834 watts after a period of time. So its actual output is 834. All right, so let's go ahead and see what happens if we drive just 2 channels. 93.14 volts, about 2,200 watts per channel times 2. That's 4,000 watts. We can look at the other one to make sure that it's doing it. And it's doing it consistently. It's just putting out a solid 4,000 watts, RMS, 2,200 watts per channel times 2 channels. That's pretty incredible. Let's try 3 and see what happens. Now we're starting to see it modulate, and we're seeing a reduction in power. So with 2 channels driven, it has no problem putting it out for an extended period of time. But when you go to 3 channels, it starts to drop down. And that would be the issue that people are talking about Class D amps, or at least this version of Class D amp, but I think that it's pretty common. It's not these capabilities of putting out massive amounts of power, but when all the channels are driven at the same time, it doesn't have the capability of delivering it everywhere at once. Let's try 4 channels. Now it's really kind of trimming down its output. But back to the original question, Class D versus old school amp. 1 channel of this Class D amp puts out more power continuously, non-stop, than this entire Class AB or Class H, which is a Class AB amp that has low voltage rails and high voltage rails, and it jumps to the high rails to get more output and be a little more efficient. So this entire old amp, this 50-pound amp, is equivalent to 1 channel of the new amp. And 2 channels of the new amp would be equivalent to 2 of these. And 3 is pretty close. Not quite 3 of these. So do the new amps, or does this new amp drop down? Would it be a little less effective for long bass notes, EDM? Yeah, that would be annoying if you're loading down all the channels and using it to its fullest. Would you go back to old school amps? Well, you'd have to have 3 times as many and 4 times the weight in order to equal it. So the answer is just don't load down the Class D amps all the way. Now, if part of this amp was driving lows and the other part was driving high frequencies, then you're not going to run into as much of a problem because you're not loading down the amp in the same way. So you could have subwoofer, lows, mids, or subwoofer, mids, highs, whatever it is. But if you dedicate an entire amp to subs, it's going to really be pinched. Dollar per watt? It really depends. You've got the ability to buy used boat anchor amps really inexpensively. So if you can haul them around and you got the space, dollar per watt, you probably could win with the older amps. Watts per cubic foot, the new amps are just going to go to town. There's just no question that the new amps will put out more power per cubic foot. Per pound, there's no question. The new amps will put out way more power per pound. This amp puts out, if it's just 2 channels driven, puts out 4,200 watts versus this one here with both channels driven barely gets to 2,000 watts. So it's over double. And with the extra, then you got 2 free channels and it's lighter. What about the current draw? What about how much juice this thing is pulling from the wall? So let's go ahead and compare one channel of the new amp. We knew the Crest amp pulled about 40 amps. Let's see what one channel of the new amp pulls. $30 amps. Watts per breaker size, per circuit breaker, per feed into the building. The new amps will give you the ability to deliver more power. It draws less. Watts per wire gauge. Let's go ahead and drop this down to 10 gauge instead of double 10 gauge. 22 amps. And we'll go ahead and give it more copper. 21.6 amps. So it pulls a little less current off of the thicker copper. This is another really interesting concept. Because there's more copper, we have less voltage drop, and therefore it doesn't need quite as much current. But the output voltages aren't changing. 93.6, less copper. 93.6. So it's delivering the same amount of power. The amp is smart enough to deliver the same power even if the line voltage is dropping and less voltage, it just pulls more current. So if you have a fixed wire gauge on your feed, you're going to get less voltage loss with the newer style amp, and the newer style amp is not going to be affected by it. The older amps, if there's voltage drop on the AC lines, it will tend to affect the output slightly. I did another video on that. It doesn't affect it too much. All right, so $ per amp drawn through the AC breakers. Smaller breakers, more flexible with the wire. The only real awkwardness that I'm seeing is this kind of compression, this limiting that's happening where the amp is protecting the feed. Instead of this thing going pop with the breaker, it's turning down the output. Which of those would you prefer? It's not all the newer amps, not all the older amps have breakers, but in this scenario, I'd rather it turn down than shut off. But the turning down and that modulation of the output to protect the amp and the current and the draw through the circuit breaker is something to be aware of. And it's not that the new amps won't do EDM. It's that you have to have the knowledge and understanding of what the amp's doing, use it properly, and then optimize it. Like any tool that we have, optimizing the tool for the job will get you better results. That's my take on it. I'd love to hear what you think. Cool. All right, this thermal indicators seem to be letting us know that we are beyond the gummy bear realm. Even the gummy bear sitting on top of the Reese's peanut butter cup has melted, but the chocolate seems to be fairly intact. Let's see what it, oh, well, it's just an illusion. Ow, that's kind of hot. That's definitely indicating something. Now the Kit Kat chocolate doesn't quite melt. Ooh, look at this, I can get the bar off. That's gonna be delicious. And a little afraid to touch the gummies because I might get molten. Now this Milky Way, it's really kind of holding together. It's interesting to see. I wonder which. This is an indication of the quality of the chocolate. All right, we're gonna have to do some further analysis on the thermal indicators.